So financial management, even those people whose papers were restated, you heard that you're not supposed to do the MA and PFT. Those people who are to do the AMA, not AMA but MA and PFT, now you are not supposed to do those papers. Even if you had booked, you have to download another timetable which has no those papers. I think that is a good news because you had done those papers in the foundation level. Previously it was called section 1 and 2. Since you had done those papers and you were told to do them in the advanced, in the intermediate level, at least your cries were heard by CASNEP, and you're not supposed now to do the paper coming December. So if those were the only people that you are sitting for, if the PFT, I'm talking about this because I know this is the intermediate level student who I'm dealing with, the PFT and MA. The PFT and MA that you had registered, now you're not supposed to do them. And this applied to those people who had done these papers. Those who had done these papers in the old syllabus. That information is important to you so that you can concentrate now to the remaining papers. So if you had 4 papers, including the 2, that means you're going to do 2 papers coming December. So you can concentrate all your energy in those remaining 2 papers, and then you proceed to the next level. Therefore, financial management can be a paper that you cannot miss to do, and that's why we are here today. So there are some of the topics under financial management. Of course, topic 1, 2, 3, those are theory topics. You cannot afford to fail. You cannot afford to fail any question under theory. You cannot afford to fail any question under theory. Being a financial manager, I know you are a manager somewhere. I know you're doing some work somewhere related to your field. So there are questions which are general to you. There are questions that are, when you put the shoes of a manager, there are questions that CASNEP will present to you, and you cannot afford to fail those questions. So in a theory question, don't fail any theory question when it comes to that exam. Topic number 4 talks about time value of money, of which this is the key. Time value of money. Time value of money. This is the key to everyone, every student. If you are going to sit for this exam coming December, make sure that you have this concept at your fingertips. Make sure that you have this concept of time value of money at your fingertips. There are 2 things that I would like you to concentrate on. Concentrate on discounting. This is a concept that cut across, and then we have compounding. Discounting and compounding, we can call them techniques. These techniques are very important as far as CASNEP exam is concerned. Financial management paper is concerned. Going to any CASNEP paper without this background, for sure, utaona giza. You're going to see darkness. You're going to see darkness in that paper. You need to have the concept of discounting and the concept of compounding. Maybe to start with, if I may ask, what do we mean by discounting technique? What do we mean by discounting technique? What is happening? When you hear of the term discounting, what comes to your mind? Let's talk. This is an interactive session. I'd like to hear from you as you hear from me, so that at least at the end of the day, we gain. So what comes to your mind when you hear of the term discounting? What comes to your mind when you hear of the term discounting? Getting present value over future cash flow. That is Murray and the friend there. They're saying that getting or converting future value into present. Thank you so much. And vice versa is true. Compounding, you're trying to convert the present value into future. Now, there are some of the factors that we do use to help us to do that. For example, if I talk about discounting techniques, If I talk about discounting technique, I'll be dealing with that since Muleli has told us that we're trying to convert the future value into present. So you'll be given some future cash flow, or you will be given some cash flow, and the examiner will require you to determine the present value of the given cash flow. For example, if I say that there will be a discounting factor, and this discounting factor, if you are discounting regular cash flow, that is one, and they will be used when you are discounting irregular cash flow. So for the regular cash flow, we mean the cash flow that are uniform cash flow. Of course, this will be non-uniform cash flow. So when you are discounting regular cash flow, the cash flow that are similar, the cash flow that come as not as a lump sum, but they are similar each year, we are going to use PVFA, present value, interest factor of annuity, present value, interest factor of annuity, and this is famous known as PVFA. Allow me to put it down here. This is famous known as PVFA. Anytime you want to convert, the future value or the future cash flow into present, maybe you are valuing a certain building, you're valuing a certain asset, you want to know its value as per today. If the cash flow are similar, you're going to use this factor known as PVFA. And PVFA formula is 1 minus 1 plus R raised to power negative n, all these divided by R, where R represent the rate of return, N represent the number of period. How many years are you dealing with? So when discounting similar cash flow or regular cash flow, we use PVFA, and the PVFA formula is given by 1 minus into bracket 1 plus R. I've said that it represents the rate of return, or the required rate of return, and then N is the number of period, where R is the rate of return and N is the number of period or number of years. That way, you will be in a position to obtain the present value of a regular cash flow. When you come on the other side of the irregular cash flow, if you want to discount irregular cash flow here, you use the present value interest factor. I want you to know note something here, that for this one we just use PVF. The formula for PVF is 1 plus R raised to negative n. Please note the two formulas. This is the formula for discounting regular cash flow, known as PVFA. Annuity. The term is annuity. You're having similar cash flow each year. Then we are having PVF. This is the formula for discounting irregular cash flow, known as PVF. This is a background that everyone should know. Then we have another term. Known as initial outlay. I'd like you to note this term as well. You get across this term, initial outlay. Which another name that fit that name? which another name that I can give to that name to mean the same? Somebody very fast. Initial outlay, as the name suggests, initials, starting. It is the same as initial investment. Initial investment. I can say starting outlay, initial investment. Initial investment. Maybe examiner tells you that the project initial investment is 30,000, and the following cash flow for the 5 years are provided, and the following cash flow for the 5 years are provided. Illustration. So we say that initial investment of the project is 30,000. Initial investment of the project is Kenya shilling 30,000. Let's deal with the Kenya shilling, and then you are told that the following cash flow of the project are provided. The cash flow we have year 1, 2, 3, and 4, and then we have our cash flows here. This examiner is good, giving me cash flow of 20,000. Here I have 10,000, have 3,000, and then here I have 5,000. I want a good student to tell me which type of cash flow am I dealing with here. That is the first step. You determine the type of cash flow that you are dealing with, and we have two: irregular cash flow. I can see from Margaret and Jennifer, they're telling me that we are dealing with the irregular cash flow. For sure, they are right. They are very right. They are very correct. I can see that year 1 I'm having 20,000 as a cash flow, year 2 10,000, year 3 3,000, and year 4 5,000. Therefore, to discount these, am I going to use PVFA or PVF? I want to discount these to get the present value. The question will be determine the present value of the project. Determine the present value and the net present value. Net present value of the project. Thank you for those answers. So in this case, since I'm dealing with the irregular cash flow, I'm going to discount using the PVF. Since I'm dealing with the irregular cash flows. And therefore, for me to do that, I need to find my PVF. The rate of return. Use rate of return as, I can put it up here. Initial investment of the project is 30,000, and the rate of return is 12%. 12% is 12%. So if the rate of return is 12%, remember you can use a calculator as well as the table. There will be a table provided by the examiner at the end of the paper, at the end or at the back of the paper. You can as well use what? You can as well use a calculator. So in my case, I know the formula of PVF is 1 plus R raised power negative n. So for the first one, I'm going to have 1.12 raised power negative 1 to get the PVF for the first year, 89, 29. I do the same for the second year, 1.12 raised power negative 2. I'm getting 4 decimal places. I'm getting 0.979, 79.72. The same case to the third year until the fourth year, 1.12 raised power negative 3. I'm getting 71.18, 0.7118, and the last year is 1.12 raised power negative 4. So in this case, I'm getting 63. 55, 0.6355. I can get my discounted cash flow here. Discounted cash flow. Allow me to abbreviate it in that order. Discounted cash flow. So I have to take my cash flow here. I multiply by the PV. My cash flow here, I multiply by PV. I'm going to show you a technical question under this, which you may expect coming December. So 20,000, I multiply by 0.89, 29. I'm getting 17,858. 17,858. You can confirm with me, my VAR people. This will be simple. It will be 79,720. 79,72. 3,000 times 0.7118. I'm getting 2135.4. 2135.4. Then the last one is 5,000. I multiply by 0.6355. 6355. 3177.5. 0.0. Then I can get the total. Of that plus 2135.4 plus 7972, and then I add my 17,858. I'm getting that 142.9. I don't know what you are getting, but I guess you're getting the same as I'm getting, 42.9. Now, this is the present value, the total present value of the project. Assume this was project B. This is the total present value, that 1,142.9. But now, maybe someone, an investor, approached you and asked you whether this project is viable or not. Meaning of the viable, it means whether the project is profitable or not profitable. What could you tell the investor? You go ahead and find the NPV of the project. Who can tell me how we get the NPV, net present value of this project? You take the present value, total present value of course, you minus the initial outlay. So can you give me the NPV of this project and tell me whether the project is profitable or not profitable? What is the NPV of our project here? Somebody is giving me the NPV now. Somebody is giving me the NPV here and telling me, advising me whether to invest in that project or not invest in that project. What is the NPV here? NPV, I'm getting 1142.9. 1142.9. That's true because I had an initial outlay. The initial outlay of the project was 30,000. The initial outlay of the project was 30,000. Therefore, I've already recouped my initial investment. This investor has already recouped the initial investment. Therefore, on top shows that this project is viable. The project is viable. So I'll be having that 142.9 minus 30,000, which will give me 1142.9. Which means that that is a positive NPV, and if a project has a positive NPV, that means the project is viable and it will bring some return. The project will bring some return once undertaken. Before we continue, I'd like to know whether we're together up to that point. Please confirm whether we are together up to this point. Please confirm whether we are together up to this point. Confirm whether we are together up to that point before we go to a more sensitive question, a most sensitive question regarding the same. Can see people are confirming that we are together. Good. Now I want us to go to another question, still under the same that examiner will bring to you, and you will wonder where to start, how to treat the question. Do not forget that you're getting this free class from RCM College. And if you have not joined our broad revision you can maybe purpose to join us. You can purpose to join us. So assume you given project B. Project B, so that the initial investment or initial outlay of project B, project B is 20,000. Of course, Kenya shilling, ama tutumie dollars. Kenya shilling inakuwa valueless siku hizi, yeah? 20,000, and then you told that the required rate of return, required rate of return is 10%, and then the cash flows of project B are as follows. Cash flows of project B are as follows. I want you to follow this because I expect CASNEB to bring such a question. The cash flow for project B are as follows. So in our case, we shall be having the cash flows here, and our years will be at this point. Therefore, we have year 1, year 2 to 3, year 4 to 5, then year 6, then we can have maybe year 7, or I can have year 7 to infinite. Year 7 to infinite. So year 1, my cash flow for year 1 will be 1,000. Or do I put 10,000? I can put 10,000. Then the rate of the year 2 will be 5,000. Then here I can have 7,000. My year 6 can have 8,000. No worries. And then year 7 to infinite, I will be having 9,000. Still the question comes, determine the present value and the net present value of the project B. Determine the present value and the net present value of project B. I want you to be very keen here. When examiner give you such a question, please do not panic. Why should you panic then? There's no reason for you to panic. Just come and look at whatever examiner has provided. Examiner here has given you some of the ranges. Year 1 has no range. Year 2 to 3, there is a range. 4, 5 range, no range in year 6, then 7 to infinity. First of all, you need to understand, how do you get the present value of an infinite figure? How do you get the present value of an infinite figure? Please note this formula somewhere. To get the present value of an infinite figure, in fact, it will be 1 over R. I can see somebody is giving us that. Thank you so much, Margaret. Yes, present value of an infinite is 1 divided by the rate of return. 1 divided by the rate of return. So when I look at this question, which type of cash flows are these? Hapo ndio watu wengi huwa wanaanzikia. Which type of cash flow are these? I'd like to know whether we are together. Which type of cash flow do I have? If you can't understand, please also tell us that you cannot understand, so that at least we are able to help each other. We say that we are regular and irregular. I like this. You people, you are bright students. Yes, you're having both regular and irregular cash flow. And why do you think examiner went ahead and tried to bring the ranges to confuse student? As student, we come here and work this question as the way we have worked that, seeing that these are irregular cash flow. And that student will come out of exam room saying that, you paper, UFM bwana, UFM nimegonga, you nimechapa. But wakati mtihani imetoka, wakati results zimetoka, what do you expect that student to do? The student has already got a fail. Because of overconfidence and lack of understanding. These cash flows are not irregular cash flows because they are mixed up because of the range here. So you should also look at the type of the years that the examiner has provided you with. Now for year one, this I know it will be a one-time thing. Of course, this is a irregular cash flow. This will be irregular. But for the range 2 to 3 year, this is a regular cash flow. It will be a regular cash flow. Why am I saying that year 2 to 3 is a regular cash flow? Because of this reason. Year 2 to 3 is a regular cash flow. Only that examiner have hidden something. Examiner have just hidden something. Look at year 2, year 3. Year 2, year 3. We have 5,000. So that means the cash flow for year 2 is 5,000 and the cash flow for year 3 is 5,000. Naona venye examiner anafanya. So is this a regular or irregular cash flow? Is it a regular or irregular? Is it a regular or irregular? It is definitely a regular cash flow, but ameificha hapa so that uone kama zote ni irregular. Therefore, when it comes to a range, when you are looking at the present value, please remember PVFA. Asikudanganye tena. Remember PVFA tafadhali. Remember PVFA. So the formula that we are going to use there is 1 plus R raised to power negative n then divide by R. Ukishamshika hapa hivi tutakuwa well done. Well done. So for the year 2 to 3, it will be regular cash flow. Can put it there. This is regular cash flow. This is regular cash flow. And now this will be irregular, and irregular. But the rate remain. The quality of return remain to be 10%. Therefore, I think with that we are able to solve this question, and you see how it is supposed to be solved for us to get the total present value together with the net present value, since we are given the initial outlay. So in this case, we have to put PVF. You can put PVFA or PVF, whatever, because we are going to apply the two PVF, PVFA, mwekea hivyo. Of course, when you do that, when you do this, you not confuse your mind. Of course, you have organized your mind that you're dealing with the PVF, also you will be dealing with the PVFA. So in the first case, and remember the infinite, you're going to use 1 over R to get the present value, so that you're in a good position to get what the examiner wants you to get. So in the first case, we can start with this one. And I'm going to use PVF 10%. So it will be 1.1. PVF. In your PVFA, and 1 plus R with negative n. This is PVF. So allow me to use 1.1. I raised to power negative 1. And I want you people to follow here. What's the time? 32. Okay, still we have time. So you have captured this. Raised to power negative 1. I'm getting 0.9091. Yes, thank you so much. Thank you so much for being the VAR people. Then when I come to the range here, year 2 to 3. Naweza kaa hapa sana because I want you people to understand. Year 2 to 3. I'm going to find the PVFA for 3 years. Please get here. Get this here. I'm going to find the PVFA for 3 years. PVFA 10%, 3 years, minus PVF 1 year, 10%. 1 year, 10%. Why am I doing this? Because I want to get the PVFA for the range between 2 and 3. So nitatafuta PVFA ya zote and then nitoe ya hiyo mwaka ya PVF. Have you understood here? Umeelewa hapa? Hapa ndio watu wengi huwa wanakosea. Have you understood this point? Please. Hapa mnafaa okay, no, I can see no. Okay, kuna yes here. So, if you want to get the PVFA of the range year 2 to 3, since we said that this is the range, and the range we are going to use PVFA, right? Ndio hii ikiwa imetengenezwa hivi ndio hii range, and we're going to use PVFA. So to get the PVFA for this cash flow, for year 1, year 2 and 3, you see those are 2 years. But now we had another year before we get to that range. We had another year. This is year 1, and this year was a PVF. In fact, its cash flow was irregular. Its cash flow was irregular. Therefore, for us, we're going to get the PVF of the 3 years, PVFA of the 3 years, and then we eliminate the PVF of the first year because we don't need that. We don't need that. Itakuwa included hapo, alafu tutoe hiyo yenye hatuhitaji. Are we together now, Catherine? Are we together? Are we together? Now, I want us to look at the PVFA for this. It will be 1 minus 1.1 raised power negative 3. Remember, we have taken 3 purposely because we need to sort this. Divide by 0.1. 0.1. Pata ngapi? Somebody to give me that. Somebody to give me that. I'm getting 2.4869. 2.4869. 2.4869. This is the PV for 3 years, but I had the PV for 1 year here. So I eliminate this to get the range now, year 2 to 3. So I eliminate that one minus 0.9091 minus 0.9091. Hapo ndio watu wengi huwa wanakosea. So I have 2.4869. This was 69. 2.4869 minus 0.9091. I'm getting something to do with 1.5778. Now that is the figure that you put here. 1.5778. That is now the PVFA for that range. The same case apply here. We're going to look at PVFA for 5 years, and then we subtract this. Zenye ziko hapo juu. Somebody video is on here. I don't know who. Corins, please. How are you, Corins? How are you? Please don't interfere with other student bandwidth, so that at least we are able to concentrate. Thank you so much. Thank you so much. So in this case, we're going to find the PVFA for 5 years. We're going to find the PVFA for 5 years, and then we less the above, what is above there. What is above there? In fact, we shall less PVFA for 3 years. PVFA 10%, 5 years, minus PVFA 10%, 3 years. Nitakuwa nimepata hiyo, na mwingine atasema PVFA 10%, 5 years, alafu atoe hizi mbili in summation of the two. Summation of the two is the same as PVFA 10%, 3 years. So let's look at it 5 years. So I'll be having 1 minus 1.1 raised by negative 5 divided by 0.1 minus PVFA for 3 years. Tumepata ni 2 point what? Ilikuwa 2 point. Hizi mbili. You can just add them. Plus 1.5778. 4869. So let me get this and see. So it will be 1 minus 1.1 raised to negative 5. I divide by 0.1. I'm getting 3.7908. 3.7908 minus 2.4869. And whatever that I get is the range of what I want, 3.7908. Thank you so much. Already people got it. 3039, 3039 minus 2.4869. Yeah, 3039. 1.3039. Thank you very much for knowing that. 1.3039. And then I have this one is a direct one for 6 years. So I'll be having 1.1 raised to negative 6. Na hiyo sasa ni mwaka moja tu. Hiyo sihitaji kufanya kitu kingine. 0.56 45. 0.5645. And then the last one is 1 over R, and then nitoa hizi. Of course itakuwa this one. Hii yenye nimepata hapa ya 5 years. Niongeze what? Niongeze year 6 year. So nikuje niongeze 0.5645. Itakuwa 3 5 is 5 kale 13, 3 by 1, so 4 point. So 1 divided by R, 1 divided by 10, R is 10. 10% of course, so ni 0.1, 0.1. Hey, I'm getting 10, getting 10. 1 divided by 10 is 10, right? 1 divided by 0.1. So I'll be having this for infinite, 7 to infinite, 1 divided by R, which is 0.1. I'm getting 10. So it will be 10 minus 4.3553. 553. Yeah, it's 10. So 10 minus 4.50, that 553, 4.3553. I'm getting 5.64, 14, 5.64, 47, 5.64, 47, 5.64, 47. So if you want to get the 4.5 forever, it is the same as when you add all these. When you add all these, is it hadi hapo hizo tunatoa ndio hii yote up to 5 and then up to 6. Umemaliza. And then once you get that, you can now multiply all your PB and PB4 to get your discounted cash flow here. Discounted cash flow here. So I can have this is a direct one, 1991. 5,000 times 1.5778. I'm getting 7889, and then 7,000 times 1.3039. So mtu asikudanganye the way to do this. And then I have 8,000 times 0.5640, 4516. Let's see whether this project B is a viable project. 5.6447. Let's see whether it is very much. 5802.3. So these are viable projects. So let's get the total present value. I add all these. Total present value can add all these. So answer plus 4516 plus 9127.3 plus 78. This is plus 78, 89, and then the last one I have 9091. So if I add the two, the 5, I'm getting 81, 425.6, 425.6, and that way I can see since the initial outlay already I have recouped, or this investor amepata chenye alianzia nayo already from here. So that this project is viable. So to get the NPV is equal to 81, 425.6 minus 20,000, which will give this investor an amount of 61,425, 61,425.6. When you are analyzing the project, sometimes examiner will give you different project, right? You'll do the same, and then you can look at the NPV. Some project will be having higher NPV, other project will be having lower NPV. So the project with the higher NPV, it's recognized first. You recognize the project with a